Hey everyone. So if you're gearing up for a senior, staff, or principal level C++ engineering interview, you already know the deal. Just knowing the syntax? Yeah, that's not going to cut it anymore. At the highest levels of tech, passing a C++ interview requires an entirely different, seriously high-stakes skill set. These evaluators aren't just checking if your code compiles. They're digging in to see if you understand the deep, sometimes pretty dark mechanics of the language itself.
Today's explainer is an exclusive What's Inside preview of the highly acclaimed C++ Pitfall Study Guide. We're going to distill the absolute core strategies and the tooling masterclasses found inside. By the end, you'll see exactly why this resource is an absolute career changer for anyone aiming for those top-tier engineering roles without losing their sanity to random seg faults along the way. And hey, real quick, if you find this preview valuable, you can actually support the project on Ko-fi to unlock the full comprehensive study guide.
Okay, let's dive into this. Here's our roadmap. We'll start by decoding senior-level interviews, move on to frameworks for high-scoring answers, unpack the modern tooling arsenal, look at catching bugs before production, and finally, wrap up with a 4-week study plan. Let's get to it.
Section 1. Decoding senior-level interviews. First up, we really need to understand what evaluators are actually looking for at the absolute highest levels. Before you even step into that interview room, or, join the Zoom call, we have to establish a crucial contrast. If you're interviewing for a standard senior engineer role, they basically want you to know the rules and idioms. They want to see you write correct, modern code right off the bat, using RAI, the rule of zero, no raw owning pointers. But if you're aiming for staff or principal, totally different ballgame. You have to connect your language decisions to the actual systems in the broader organization. You need to be talking about ABI stability, build time impacts, and overall toolability. Honestly, if you just memorize syntax, you'll completely bomb the systems level evaluation they expect from a principal. You've got to frame your choices as trade-offs against named alternatives.
All right, moving into Section 2, frameworks for high-scoring answers. Now that we know what they want, how do we actually frame our answers to score maximum points?
Now, what's really interesting about this is the three-part framework: rule, reason, exception. When they ask you a question, don't just state the rule. You state the rule, you explain the foundational reason why that rule exists in C++, and then, this is the absolute kicker, you volunteer the exception where that rule should actually be broken. For instance, you could say, move constructors should be no except, because standard vector's strong exception guarantee forces it to copy elements on reallocation if the move isn't guaranteed safe, right? But then you hit them with the exception. However, for types where a move inherently allocates and genuinely can fail, you either accept copy on grow or you terminate. Articulating those deep design constraints, that shows true senior judgment.
Building on that, here are some advanced framing tactics you absolutely should be using. First off, name the era. Don't just explain how something works. Say, well, pre-C++ 17, this was just an optimization, but since C++ 17, it's guaranteed because pre-values are redefined. That signals that you're constantly learning. Second, volunteer the cost model. Talk about cache lines, allocations, atomic read modify rights. Put concrete numbers to your intuition. And finally, it's totally fine to say the committee got something wrong. If you bring up std vector of bool being a bit-packed proxy mistake, or how dot size or turning an unsigned integer can cause arithmetic traps, that kind of informed criticism reads as deep seniority, not just complaining.
The guide itself includes an extensive, high-frequency question bank. Here's a rapid-fire teaser of the kind of intense questions you need to know cold. What does std_move do exactly? Hint, it doesn't actually move anything, it's literally just a cast. What's the rule of zero, and what silently suppresses implicit moves? How does shared underscore PR internals work with the control block, and what's the hidden cost of those atomic reference counts? Do you have the iterator invalidation rules for every single container memorized? If any of those made you hesitate even for a second, well, you've got a knowledge gap that this guide will absolutely fill. Let's move to Section 3 and see how this builds into the modern tooling arsenal. It's time to pivot from just answering questions to proving your on-the-job mastery.
At the principal level, interviewers care way less about can you spot this one specific bug? Instead, they want to know what system are you putting in place that prevents this bug class from ever shipping. The crucial point here isn't whiteboard bug hunting, it's demonstrating exactly how you deploy automated tools to catch every single C++ foot gun automatically across an entire engineering org.
To answer that effectively, the guide provides this exact categorization matrix, and honestly, you should be able to reproduce this from memory on a whiteboard. First up, compiler warnings, your standard GCC and Clang flags. This is basically the free tier that nobody ever maxes out. Then you move up to static analysis. Things like Clang Static Analyzer, CodeQL, and CPP Check. These are perfect for your pre-commit CI tier to run semantic queries. And finally, the commercial or deep tools, Covarity, PVS Studio, MSVC Analyze, which do heavy, path-sensitive analysis and leverage lifetime annotations. If you can confidently walk an interviewer through this entire matrix, you instantly separate yourself from the pack.
Section 4. Catching bugs before production. Let's look closely at how these specific tools act as an impenetrable shield against those classic C++ foot guns we all dread.
And this brilliantly illustrates the power of those tools. Take simple compiler flags. By just turning on W-pessimizing move and W-redundant move, you automatically stop developers from writing a return std move on a local variable, which literally blocks guaranteed copy elision. Or look at W-reorder. We all know C++ initializes class members in declaration order, not the order you wrote them in the constructor's initializer list, right? Slapping on W-reorder catches massive initialization headaches before the code even merges. And when you bring up tools like CodeQL in an interview, you can talk about writing custom semantic queries to find, say, all string_view fields accidentally initialized from a parameter. You're completely neutralizing dangling pointer risks for the whole organization.
Section 5. A 4-week study plan. Let's transition into our highly actionable wrap-up, the exact roadmap provided in the book to conquer all this material. To get you through this mountain of information, the guide perfectly chunks complex, systems-level concepts into a manageable, progressive 4-week spread. Week 1 hits the value semantics core, stuff like initialization, object lifetimes, and move semantics. Week 2 dives into the dark corners of polymorphism and templates, tackling two-phase lookup and sphere. Week 3 gets into library and memory, so mastering iterator and validation and the exact definitions of undefined behavior. And then Week 4 brings the whole shebang together with concurrency, errors, and systems, drilling deep into data races, memory models, and compilation ABI issues. Throughout this entire sprint, the guide heavily pushes using Compiler Explorer, Godbolt, for every single claim about code generation. It is an absolutely golden study habit. Seriously, if you're in a staff-level interview and you casually drop the phrase, "Yeah, I checked what this compiles to," it is a guaranteed win. It proves you don't just blindly trust the theory, you actually verify the assembly.
So, what does this all mean? The ultimate question is, are you ready to pass the deep understanding gauntlet and claim that staff or principal role? Remember, this explainer was just a high-level teaser of the extensive strategies, question banks, and deep dives waiting for you. Head over to Ko-Fi to support the project and unlock the complete arsenal today. Because at the highest levels, the difference between a mid-level coder and a principal engineer isn't just what code they can write, it's what bugs they can systematically prove will never exist. So, are you ready to pass the gauntlet?